Hello everybody, I'm Alexy Khrabrov, the organizer of SF Text, a new meetup devoted to text mining, AI, search, NLP, and basically discovering human intent behind, the strings of text. And this is our second meetup. We're here at Lithium, and we have Adithya Rao, lead research engineer at Lithium with us. And we formerly were colleagues at Cloud, so I know quite a bit about Cloud. And the topic today is topics, which is something that Cloud does really well, and Adithya works on is going to talk about tonight. So we'll have the talk separately. So I'm just going to ask a few questions to kind of get more perspective on this whole space. So it's great to have Adithya with us.
Thanks
for hosting us.
Yeah.
So how did you get interested in this whole space? I know that, what you were doing at Cloud, and you're really interested in the science of these things, how they work. So can you tell me a little bit about your background, and what brought you to these problems?
Definitely. I think it started mainly when I started looking at I come originally from an electrical engineering background, and I was looking at wireless networks as my initial field of study.
Okay.
From wireless networks, communication was a kind of an easy walkthrough, and there information theory became like a very interesting subject. As I started going deeper into that whole, I realized that it's probably easier to work with when you look at it from a higher abstraction, and that's when I kind of moved into the domain of like machine learning in particular. So I did my master's from Stanford, and there I mainly specialized in machine learning and data mining, and that really got me interested into the various domains where you can apply machine learning, and text was one of the big ones, and that was around maybe 4 years ago when the social media boom was just like taking off. There were a lot of people, everybody getting overwhelmed with so much data around, and I thought it was a perfect opportunity to kind of look at information in social media and how machine learning can be applied to that aspect. And so I joined Cloud at that point, and basically there was this huge data set to work on, and it's been pretty exciting.
Yes. I know, some of the story, and that's, it always amazes me that, with a relatively small team, Cloud was able to achieve so much, right? Because so now, as I understand, it ingests essentially most of the social web.
Yeah,
right?
A lot of it, yes.
I remember, it was quite a few iterations to get there, but how do you find balance basically with, a kind of a startup setting, to be able to regularly, daily, ingest all of this data and do some science on this? Like how do you balance the engineering work versus the research work?
Right. So I think the important part is the engineering work at the end of the day, because unless you're able to consume this kind of data and build up frameworks that allow you to kind of iterate quickly or try to do things where you're able to push things out fast to production and so on, no matter how complex your algorithms are, it's not going to amount to anything at the end of the day. So I think that is where like a lot of effort went in the beginning years of Cloud at least, and finally, when we did have a framework where we could ingest this data and run like pipelines every day, then it became easy to kind of, let's try out this algorithm, let's try out this model, let's try out these features, let's maybe vary it up a bit, and then maybe the cycles became faster and iteration became faster. So I guess engineering plays a very big role when it comes to data science, although when we talk about data science in particular, we often ignore that aspect of it.
Yes. So I remember you used a lot of different tools, we were at Cloud. Can you talk a little bit about what kind of tools are you using in your daily work?
Sure. Yeah. So I think most of the for machine learning at least, we use most of the standard ones like Python libraries and Weka and so on. But in terms of the data pipeline, we use mainly the MapReduce stack with our HDFS and Hive on top of that for our querying language. Hive is actually a pretty powerful abstraction because it allows us to write like complex queries which trigger like multiple jobs without actually worrying about how you would go about optimizing those things. And the really interesting part is also that it allows us to have UDFs, which actually encapsulate a lot of the complex logic that you may not be able to write in Hive, but you end up, let's say you wanted to apply a predictive model to a row in Hive, you would want to have that as UDFs that can maybe look up some data from different sources, do some extraction, do some NLP, and then apply a model, and all of that can exist in a UDF. So I think that combination of the Hadoop stack along with the ability to write UDFs and then training offline models using machine learning tools has really kind of helped us in scaling up.
Cool. So, so when you're doing, it's very interesting because you're doing, using both Python and Wiki. And, one of my huge drives in the Scala community is to kind of bring scientific computing to the JVM. Right. And so there is a lot of libraries which exist already, but there are some gaps compared to Python. And there is just a habit of a lot of data scientists to use Python because that's usually the first language they pick up in school.
It's also probably the most developed in terms of machine learning, because there are so many tools that are present over there. But yeah.
Right. So that's my question to you is kind of practicing with both tool sets. What does the JVM community need to do to kind of bring the Python functionality, right? Where do you see the most gaps and where the community can contribute the most? And what should happen so for you to stay within the JVM when you do your experiments?
Right. I think the main thing is the comprehensive nature of the tools that are present in Python. I think a lot of the algorithms that are present in like the Python toolkits are not always present in the JVM toolkits, and maybe if they are present, they're not implemented in a fashion that is very efficient when you want to scale up. So I think a lot of there are a lot of small things which the smaller pieces, once they are there and they kind of build up like Lego bricks, that's when maybe the JVM community would be at that same scale. I'm looking forward to using Spark MLlib. I haven't used it personally yet, but that seems to be a promising area which could combine like the advantages of streaming data along with some of the machine learning libraries. So I'm sure like there are a lot of avenues for implementing a lot of the things that are existing in the Python toolkits into the JVM space.
Yeah, and Spark also will run Hive, right? Because they're committed to run everything on Spark. So there is Spark SQL, but also Hive itself will have Spark backend, right? So which is really exciting.
Yes. Yeah.
Interesting. So you mentioned NLP. Can you talk a little bit about what kind of NLP are you guys doing? What kind of tools are you using, and what works in practice?
Yeah. So I think one of the biggest things that we found in our experiments is that if you try to use like very sophisticated NLP techniques, like let's say you wanted to use Stanford named entity recognition for parsing out entities from your text, what happens is that sure, you could run that on a small scale, but when you want to run some things on 700 million messages per day, it's not going to scale very well. So one of the approaches that we took was that we actually used open data sets such as Freebase, Wikipedia, and all of these knowledge graphs. And using those knowledge graphs, we try to create dictionaries that are pre-trained and prefabricated, so that they already encapsulate all the entities that are relevant. And the advantage of doing that is also that when new entities start coming up, let's say there's a completely new phenomenon on social media today that we want to incorporate in our dictionaries, we are able to update our dictionaries very easily. So rather than trying to extract semantic meaning, of course sometimes that is very useful, but in some cases what happens is just using a simple dictionary and trying to have those dictionary terms mapping to certain entities in your topical ontology is pretty effective in going maybe 90% of the way. And sure, at the end of the day, if you really want to be like very highly accurate, you have to get more sophisticated in terms of the NLP techniques. But even doing simple techniques at scale can sometimes get you a long way if you're using the correct kind of data sets and the data sources.
Interesting. So basically you do your most of your NLP offline and when you do training. So when you do that, can you describe what kind of stack are you using to do that?
So basically we use Freebase as one of our primary data sources. So again, we use Hive to kind of extract all these entities We have a bunch of tools that we are have in the UDFs that do things like tokenization, stemming, and maybe a lot of other transformations that.
So it's on JVM as UDFs in
yeah,
in
it's all
fact.
JVM. Yes, it's all in JVM, and some of those UDFs are also open sourced in the project called Brickhouse.
Okay.
So it's actually free to use for a lot of people. So they have UDFs such as where you can pass in a dictionary and you can pass in a piece of text, and then the text will efficiently extract the certain entities out of the dictionary and so on. So we have a bunch of these UDFs which we then use to kind of extract entities from Freebase. We use certain ranking techniques and relevance techniques to say that these are the most important entities out, because there's a lot of noise in Freebase as well. So you would probably pick the cream, do some sort of ranking, pick the cream, maybe the top 500,000 keywords, and then map those 500,000 keywords into 10,000 topics, because multiple keywords would map to the same topic and so on. So mainly the stack that we use is still Hive and UDFs for building these models, with a little bit of Python to just kind of do the little bit wherever a little bit of machine learning training is required.
Interesting. So that sounds really kind of scalable production infrastructure. And I must say that Brickhouse, I think lead is Jerome Banks, who is our common former colleague now at FWE, and actually we are planning to present some of the open sourcing stages of that project at some SF Scala meetups coming forward. Interesting. So given that you kind of set up this infrastructure, you iterate it, and you have it in kind of nice, ready working production order, and you can iterate and experiment, what are the next steps? Where do you see challenges for this project in the future?
Yeah, I think one of the most exciting things for me is actually in the domain of deep learning. So deep learning is just, everybody's talking about it. It's kind of the hot area of machine learning right now. The challenge there is that if you wanted to run any algorithm on deep learning, it's debatable whether you can do it on the cloud and on the JVM. Right now, the best approaches to that have been to run it on GPUs. Now, if you wanted to scale GPUs, but now you're using something like the Hadoop stack, then how are you going to really go about it? So I think there are certain challenges there that will probably be, I'll be keeping my eye out on in the next couple of years to see how that pans out. But that is a very exciting area of research, because if you are able to do unsupervised learning using deep learning on like large corpuses, then you pretty much have like a huge step ahead than what everybody is at currently on in terms of production systems.
It's interesting you mentioned this, because we have this conference coming up, Text by the Bay, and one of the talks there actually deep learning with deep learning for J on Spark, and that toolkit actually uses GPUs, right? So because you can there is a linear algebra implementation ND4J which can use CUDA and GPUs. So hopefully, we'll make some advances there, right? And
I've looked into deep learning for J. It looks very interesting.
And runs on Spark too, right? So hopefully all this stuff will come together, and I think actually NLP is a great application, and hopefully we'll see what's next, and I think the committee would be happy to work on this stuff. Well, thanks for sharing with us, Adithya. We're looking forward to your talk.
Thank you. Thanks so much.
All
right.
Thanks.